Hello everybody, this is your video about inductive and deductive reasoning. So there's not a whole lot that goes on like math-wise with inductive and deductive reasoning. Those are just the two different types of reasoning, right, or logic that we use in math. So I'm going to give you a couple of definitions. We'll go through kind of how they're connected, and then we're mostly going to do practice problems here. Okay, so I'm just going to go through and kind of write some of these definitions out. As always, the notes are on the left-hand side of your screen, like the slides, and then I'm going to type in your student notes on the right-hand side of the screen. Okay, so inductive reasoning. The definition of inductive reasoning is the process of observing data, recognizing patterns, and making an educated guess. Okay, so it's basically what you do out like in the real world every day, right? You take in information and then you make decisions or guesses about what's going on based on that data, right? So our brains are always like constantly looking for patterns in the world because that's how a lot of our brains work. And then we take that information and we try to make an educated guess, usually about what the pattern is or what comes next. Okay, those educated guesses are called conjectures. And it's just our fancy word in geometry for an educated guess. Okay, now with inductive reasoning, you're like taking in a bunch of information, right? Um, but patterns can change when you get new information, right? You may gather information that shows that the pattern you originally thought was true was completely different. It's like making a hypothesis in a science class, and then you test that hypothesis and you see whether or not you were right. Okay, so what we have in math is another kind of reasoning called deductive reasoning, okay, which is the process of using facts, definitions, and rules, and like established rules to prove that a conjecture is true. Okay, so we start with a conjecture, we start with an educated guess, and then after that, we have to use things that we know are true, like facts and definitions, in order to prove that that educated guess is true all the time. Okay, that's what deductive reasoning is. And that's a lot of what we do in geometry, right? We take rules that we already know are true, and then we use them to make new rules, right? And that are always going to be true. And those new rules are called theorems, okay? So a conjecture or a guess can turn into a theorem once we have proven that it always is true, that it always works, okay? So a theorem is a conjecture that has been proven and is always true, okay? No matter what. And the cool thing is once you prove that a theorem is true, right, then you don't have to prove it again, right? And you can continue to use it, okay? So the way that whoops, I'm going the wrong way. Sorry, everybody. Okay, so the way that I like to explain this to people is through this kind of like diagram here. Okay, so always we start with an observation, right? We're observing something in the world. Okay, right? And then based on that observation, we use inductive reasoning. Okay, so that's when we make guesses based on our patterns, right? So we use inductive reasoning, right? We observe data with inductive reasoning and we make our educated guess, right? Remember that educated guess is called a conjecture. Okay, so we start with an observation, use inductive reasoning to make a guess. Okay, and then if we want to say, well, I think that my educated guess is true all the time, we have to use deductive reasoning or a proof, We have to prove it somehow. Okay. So deductive reasoning takes our guess, our educated guess, our conjecture from a conjecture, just a guess, to a theorem, which is just a fancy math word for a rule that's always true. Okay, so we're going to be looking at a lot of theorems in my class in geometry about lots of different things, mostly about shapes and their properties and things like that. Okay, so what we're going to focus on for these practice problems, though, because proofs, it takes us a while to get to proofs. So what we're going to focus on in these practice problems, which actually I think I'm going to do for you in a separate video. Okay, so take a look at the next video for these practice problems and the solutions to these practice problems. But we're mostly going to be looking at the first part of this, the first part of this, right? The observation and the inductive reasoning part in order to get to a conjecture, right? So we're going to look at and see if we can figure out like the next entry in a pattern and things like that. All right. So, like I said, take a look at the next video to check your answers to the practice problems. If you want to try them on your own first, don't watch that practice problem video yet. Try them on your own first, and then you can watch the video to check your answers. Or if you're feeling like you need a little bit more support and you want to work through them with me while watching the video, instead of trying them first on your own, you totally can do that and go straight to the next video. All right. I will see you all in the next one. Bye.